blah, 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 blah. Multiplying radicals can only occur if radicals have the same index. So, can I multiply this? 2 times root 7. Is that okay? Why? Because they're both square roots. Everybody cool? Can I multiply this? 4th root of a fish times 4th root of a lightning bolt. Why? Because they're the same index. What's under here doesn't matter. Just index matters. So that's okay. Can I do this? Root 3 of 4 times root 4 of 3. No, because the indexes are different. Is everybody cool? Okay. Now there's one situation where this is okay. You can do it. Could I multiply, and I'm going to write it in red, this, cubed root of 8 times root 4. Can I multiply that? Why? Because that's 2 and that's 2, so the answer would be 4. Okay. Normally they have to have the same index unless you can simplify them. Do you understand what I'm saying? Because 8 has a cubed root, I can get rid of the radical sign. Then I'm able to multiply it. Do you see what I'm saying? If this was root 5, I couldn't do anything with this because it's a cube root and a square root. Is everyone okay with that? All right. So, next thing. There's a new word there. To multiply radicals, you multiply the coefficients and their arguments. Okay? That's a math word. You already know what a coefficient is. And as a matter of fact, we just reviewed multiplying coefficients right up here, yes? So we're okay with that. Arguments is a catch-all term. It's a general term for anything attached to a coefficient. So up here, the argument happens to be x, which happens to be a variable. Everybody understand? So in this case, we multiplied our coefficients together, 2 times 2, and their arguments. There's no argument here, which technically means it's a 1, yes? And so then I multiply the arguments together, x and 1, and I get 1x. Is everyone okay with that? So in this case, the arguments are the radicals. Is everyone okay with that? Oh, not radicals. Sorry. Radicands. Everybody cool with that? Yeah? Okay. Now I want to call your minds back to something you did in the 8th grade or the 6th grade or the 9th grade. Don't write down what I'm about to write down in blue. If I gave you this, 3/4 times 1/5, what would you do? Kiara? No. I'm multiplying. No, that's dividing. I would multiply straight across, right? We remember Mrs. Bad Crumble teaching us adding fractions. And she spent 1.5 years to teach you to find a common denominator. When really all that she was doing was lowest common multiple, right? Which you guys figured out in one day. But when she got to multiplying, she said, okay, children. And she didn't say children. She said boys and girls, because that's what they all say. Okay, boys and girls, remember how hard it was to add and subtract fractions? And you all went, mm-hmm. And then Mrs. Bad Crumble said, well, now we're going to multiply. And that's the easy one, because all you do is multiply straight across. Because that's what you wanted to do when it was adding, didn't you? If I said this was plus, you wanted to say it's 4/9, right? But it, of course, isn't. So she told you that. But then Mrs. Bad Crumble forgot to tell you that numbers get big. And when the numbers are big, multiplying straight across is a stupid way to do it, isn't it? Because if I gave you this, 21/49 times 14/28, you wouldn't multiply straight across, would you? What would you do? You would simplify first, right? 7 goes into that 3 times, 7 goes into that 4 times, 7 goes into that twice, 7 goes into that 7 times. Then you would look at 2 and 4 and make that 1 and 2. 3 times 1 would be 3, 7 times 2 would be 14, and you'd have a simplified answer. Right? Right? Okay. So, I ask you this. When the numbers get confuzzling, what did you do before you ever multiplied? You simplified first. If you do that in one point in math class, what should you do every other time you're doing math in math class? Simplify first. Everybody with me? So, let's go back to what we are doing here. This question right here. What are the coefficients? I will highlight them in yellow. -7, that didn't highlight in yellow. -7 and 5. What are the arguments? Three and 8. Now we multiply them together. Now guys, I'm going to actually write it out. Okay? And I recommend for these first couple you do too, so you get it in your head. You with me? So this is technically -7 times 5, and then the root of 3 times 8. Everybody cool with that? Coefficients together, arguments together. Yes? What is -7 times 5? -35. What is 3 times 8? 24. Now, is that the right answer? It's the right answer, but it's not the simplest answer, right? Just like over here in fraction world, this is really, or could be, 294 over 1372. Is that the right answer? It is, but math guys don't want it that yucky, do we? We like our math elegant, simple, together as possible. So what would you guys do here now? We would simplify our radicands, which is what we did yesterday. Okay? Now, to remind you, 24 breaks down into what? I'm going to do the long way here first. 3 and 8. 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. Yeah? Right? How big a group am I looking for here? A group of 2. Do you see a group of 2 in there? There it is right there, right? So what comes out from under there? A 2. So 2 comes out. What was already out there? -35. And what did we leave under the radical? 6. 2 times -35 is -70 root 6. Is everyone okay? Because I left 2 and 3 under the radical sign. Because one group of 2 came out. Okay? Now guys, yesterday when we had more practice, remember I do this way. 24 is 4 times 6, isn't it? There's my perfect square, so out comes a 2. Cool? Okay, let's look at the next one. Can I multiply them together? Yes, because they're both square roots, right? Their index is the same. What is the index when there's no index? 2. Good. Is there a coefficient in front of the first term? No. So what's the coefficient when we don't write a coefficient? 1. So this is really 1, isn't it? So what do I really have here? 1 times 3 and the root of 2 times 8. Correct? Which is 3 root 16. What do I do as soon as I see a radical? I check for simplifying. What is the root of 16? 4. So this is really 3 times 4, which is 12. Is everybody good with the easy ones? Everyone? Yeah? We're all okay? All right. So now look at this next one. If we keep going the way we're going, we're going to just multiply, and I'm going to do this one in red. If we keep going the way we're going, this one would be negative 8 times 6 root 6 times 12, correct? Which would be negative 48 root 72. Everyone okay? We've done 72 a few times. I like using 72. It works real well. Negative 48, and that's 2 cubed, right? 8 times 3 squared, which is 9. Good? Is there a group of 2 in there? Where? There's a group of 2 2s, so out will come a 2. Is there a group of 2 3s? So out will come a 3. Minus 48 was already out there. And what did we leave under there? 2. When I multiply all this together, I get 96 times 3, which is negative 288 root 2. Does everybody see how that worked? This side. Whoa, I almost pulled my computer off. Does everybody get this? It's exactly like what we did up here. Yeah? Why was it ugly? What made this ugly? The 72, right? Just like in fractions, if there's a chance to simplify before we begin working, we should take it. So I'm going to go ahead in blue and do this one again. Does 8 root 6 simplify? No. So negative 8 root 6 stays the same. But does root 12 simplify? Root 12 is 4 times 3, isn't it? What's the square root of 4? 2. So this becomes 12 root 3. Correct? Now, 8 times 12 is negative 96. Root 6 times 3 is 18. Then I would simplify 18. 9 times 2, what's the square root of 9? 3. So it becomes 3, negative 96, times 3, and I left the 2 under there, which is still negative 288 root 2. Do I care which way you do this? No. But I warn you, as you get further and further along, there will be bigger and bigger numbers. For example, look at F. Do you want to try to simplify 16 times 54? Because that would be trying to factor 16 times 54, factoring 864. Yucky, right? So let's do a couple of these. This one is a tricky one because it shows you something that a lot of you guys don't notice. What is this? How should I write it out? If I were writing it out the long way, what would I write, Antonio? 3 times 1, because keep the coefficients together, root 3 times 3, 3 squared, right? What's 3 times 1? 3. What's 3 times 3? 9. What's the square root of 9? 3. So this is really 3 times 3, which is 9. Is everybody cool with that? I put this one in here to show you this thing. The square root of 3 times the square root of 3 is what? Square root of 9, which is what? 3. Notice the pattern. Square root squared is the radicand. Does everybody understand that? So if I have the square root of x times the square root of x, that is the square root of x squared, and the answer is x. Everybody good with that? No matter what the number is. Got it? That's why that's there. All right. Now look at E. Tell me what's different. There's brackets. Do we know how to deal with brackets when there's no roots involved? Again, don't write this down. I'll write it in red. Could you do this? You guys have all been through grade 9 math. Could you do that? What is the answer? 6x plus 4. Why? Because the 2 distributes everywhere in the bracket, yes? You guys all did that in the 9th grade. So what do you think happens here? Where does this term go? Everywhere into the brackets. What's 5 times 3? 15. Do I need to write it out totally, or can I go to the, assuming you get the first step? Is it okay? What's 8 times 2? Root 16. Plus, what's 5 times 2? 10. What's 8 times 3? Minus, what's 5 times 1? 5. And 8 times 5? Root 40. Now what would you do with all those radicals? No. We've already done our multiplying. What would I do with all those radicals? Starts with an S. Simplify. What's the square root of 16? What's 15 times 4? We call it a quarter of an hour for a reason. 60. 24 is what? Isn't that 4 times 6? What's the square root of 4? 2 comes out here. What does this become? Plus 20 root what? What did I leave under there? 6. What's this? 4 times 10, isn't it? What's the square root of 4? So what comes out? What was out there? So this becomes negative 10 root 10, right? Now, I haven't actually taught this to you guys. Do you think I can go any further? Thinking about what we did. What has been my example for everything we did with radicals? I used variables, yes? And it worked, right? So what do you think? Can I do anything there? Yes or no? No, of course I can't. Because this is one variable. If I use my example, isn't this different? So that would be a y. Could I add 20x minus 10y? Why not? They're not like terms, are they? I could add 20x and 10x. Or I could add 20y and 10y, but I can't add x and y. Is everybody cool with that? Okay. So look at this one. Remember, you are allowed to make this the cubed root of 16 times 54, which is the cube root of 864. Then you got to make a redwood-sized factor tree, don't you? Right? I don't want to do that. Just like I don't want to simplify 294 over 1,372. So what do I do here first? Simplify now. Simplify. Isn't 16 the cubed root of 8 times 2? It is, isn't it? And isn't 54 the cubed root of 27 times 2? Right? What's the cube root of 8? 2. So it's 2 cube root 2. Yes? times, what's the cube root of 27? 3. Cube root, what did I leave under there? 2. Do I have the same index? So what's 2 times 3? 6. Cube root, what's 2 times 2? 4. And I'm done. But Mr. Myers, I thought you said when you had root times a root, you got the radicand. Y is the cubed root of 2 times the cube root of 2. Why isn't that 2? Because it's cubed root, right? What would the cubed root of 2 times the cube root of 2 times the cube root of 2 be? That would be 2. Does everybody understand that? Everyone's cool with that? Okay. So you guys do this last one. Please tell me you are not going to try and do the 15 to the root of 1764. Are any of you going to do that? I hope not. Is that allowed? Of course it is, if you want to draw a factor tree the size of a redwood. I don't. So what should you do instead? Go ahead and try it.
Good morning. Here's your announcements for Thursday, October 20th. Doing a little bit early today because of the rearrangement of the schedule for divulging. Attention music students, VSO Mr. Deposits are due today. Bring the forms to Mr. Rao as soon as possible.
Page 81 is your homework. Just 81. I lie.
Challenge exam applications due to Mrs. McKenzie by next week.
No, just 81. Oh no, it's a 3-day weekend, isn't it? 81 and 82. You do not, there's no textbook work for it, so just 81 and 82.
Reminder to key club members that weekday applications are due by October 24th.
And if you want to see the right answer here, just watch while he talks.
Basketball tryouts are today after school in the jungle. And our senior girls volleyball team plays Poppy tonight at 7. Players should be there by 6:15 and check in with Mr. Peter's gift we need around. Next week is Halloween Spirit Days. Goes all week. Monday is Crazy Sock Day with musical chairs in the rotunda. Tuesday, Camel Day, candy eating contest. Wednesday, Mathlete versus Athlete Day with a balloon pop at lunch. Thursday, Eagle Swim Day with Mummy Wrap at lunch. Friday, Superhero Villain Day and Pumpkin and the Pumpkin at lunch. And of course, the following Monday is Halloween. It'll be Costume Day. Following suit should report to PAC at 8208. Trade now, Brandon Gunther, Rizwan Javed, Gavin Mukhtar, Tyson Reed, Tyler Rippon, Johnny Stevenson, John Shintaka, and Annalise White. And a reminder that you are to go to your next period class, and the next block for Diwali is in the third period of this morning. That is all.
Okay. Was everyone able to do that? Everyone's cool? Okay. Homework for the weekend, page 81 and 82. All right? Like I said, there was nothing new today, right? You already know how to multiply, and you already know how to simplify. So there was nothing new today. It's just practice. Yeah? Notice that your next thing on your outline is your radical mid-test. That will be Wednesday on all this stuff. Have good days. Have good weekends. Don't do anything stupid. I want to see you all back here on Monday.